How you going, guys? Curtis from Cutting Edge Engineering. So today's job, we have a cylinder rod in from a 390 cat excavator, and it has had a very unusual failure. This is the dipper arm cylinder on the machine, so it is probably the most high cycle cylinder on the excavator. This controls the movement of the dipper arm while the machine is digging or loading out trucks and stuff like that. So as you can see, the eye of the rod is in very good condition and the chrome work is in very good condition, and it is not bent. So what we have is a failure down the other end of the rod. As you can see, this part of the rod has basically shattered and it has cracked all the way around the shoulder. So I don't believe this was formed by a foreign material getting into the barrel, because there is no damage to the rod other than the failed area we're talking about. There's no damage to the piston, the barrel, or anything else. It was all contained to this one area. So I've seen this failure only one other time. It was on the same brand machine. It was a little bit smaller, but it was the exact same sort of failure. And what I believe has happened is the nut was over tightened up against the piston, which put too much pressure against that shoulder. And while the machines are working, they do go through a cycle of getting hot and then cooling down overnight. That cycle of expansion and contraction will cause metal fatigue. And over time, you end up with a massive failure like this. This area is where the choke or a cushion bearing lives. There is also one on the bottom of the rod. They slowly disperse the oil in that area to create a cushion that will reduce the speed and the impact when the cylinder closes back up into the barrel, so the cylinder rod doesn't bottom out and bang and carry on like that. The choke bearing itself is actually floating, so it's not fixed onto the rod or held in place by the piston. So you can also see that area that has broken away from the rod has actually moved forwards about a mil, which would have let the piston then float on the rod, and it has then impacted the choke bearing. It has actually cracked the choke and allowed it to expand, which has then picked up in the cylinder gland. Underneath the cushion bearing, there is a machined groove which houses this plastic reinforced fiber ring seal. It doesn't actually touch the bottom of the groove. However, that groove is a weak spot for a failure like this to occur again. So after chatting with our customer, he has also agreed that we are going to modify it and remove that groove altogether. And we are also going to eliminate this machined relief here. It'll be parallel all the way to the stop shoulder where the piston pushes up against it, and we will just put a radius in that corner, because that relief there is another place that a failure can occur. So before we can get on to making the new rod, I need to remove the eye off this one. So let's get it set up in the lathe and get into that. As you saw then, I was just using the tailstock to push the rod into the chuck, and it was moving that cracked area of that shoulder quite a lot. So it wouldn't have taken much for this to completely break off and it just to be a total catastrophic failure. The customer's really lucky they caught this when they did, and the only reason they caught it is because the cylinder was weeping oil. Righto guys, now that we've got the eye off the old rod, we can now get the old piece of rod out of the machine, set the new one up and start machining our new rod. For those of you that might be wondering what we do with the material from the damaged rods, it goes straight in the scrap bin. So we don't keep it and we don't sell it to another customer. There are just far too many liability issues with materials. There could be fatigue fractures in the rods, they can be bent, cracked, stuff like that. So we send these away to our scrap metal recycler. They will send them off and they will be recycled and turned into something else. So I'm just going to remove the wrapping off the rod to give it a quick visual inspection, so we're up to standard with our quality assurance to make sure there is no damage on the rod. I would hate to do the entire job, unwrap it and find a dent or a scratch in the chrome. This is a piece of 150mm induction hardened chrome bar. It is a 38 MNVS6 grade, which is very similar to a 4140. So it weighs 450 kilo and it is just shy of 3 meters long. So I'm just going to tape up the face of the steady. That avoids getting any chips or any swarf from the cutting tool into the rollers in between the chrome bar and damaging it. I know people out there use cardboard and plastic and they cut them to different sizes. That just doesn't work for me. I'd rather use a couple of dollars worth of tape up the face and know I'm not going to hurt the piece of material while I'm doing all the machining. So I'm just going to put a little bit of whey oil on the bearings for the steady. Bearings do need some sort of lubrication. If you do run them dry, you do have a risk of overheating them and then actually locking up and then destroying the material. A bit of oil just goes a long way. So I've drilled a center hole in the end of the rod. I've then put a live center up against that just to support the rod while it's being machined. Now I'm going to remove the induction hardened layer. The induction hardened layer is about 5mm thick. To remove that, I'm going to use a ceramic insert. They are a cost-effective method other than using a CBN insert, which are extremely expensive and just as brittle. There are a lot of people out there that would take that induction layer off in one pass, and they would do that by using a high RPM and a very low feed rate. But my issue with that is if you do have an insert burst, you've only got a split second before the tool will then engage the material and you will then have a massive problem with breaking tools and damaging material. So I take it off in 1mm passes just so I can avoid any issues and I don't have any tool collision with the piece of material. Generally, these inserts like to run either really hot and dry or you got to flood them with coolant to keep them cold. Now that we're through the induction layer, we can throw a carbide insert in there and start really removing material. Righto, so I'm just going to change out the insert. I was trying a new style of insert. It is doing a really good job, but I'm just not enjoying being covered in swarf. So I'm just going to change it out and get the swarf going in a direction where I'm not getting burnt. So we've got all the rough turning done, everything's roughed into within a couple of mil of its finished size. What I'm going to do now is go through and do the final passes to get everything to size, and then we're going to move into the finer details. Righto, now that we've got everything machined to its final dimension, I have two areas that need to be threaded. So I have the main area for the nut that holds on the piston. And I also have a thread to do on the end of the rod, and that is for a locking nut that holds on the bottom choke. Flick it everywhere.
Okay.
Righto guys, so we've got all the machining completed on this end of the rod. As you can see where the front choke lives, we did delete that groove that was there for that ring seal. I've also modified the surface area where the piston goes onto the rod and goes up against the stop shoulder. So rather than there be a relief machined into the rod, we've simply just put a radius in the corner so the piston can butt all the way up against that shoulder. Essentially what we've done is eliminated all the weak spots on that end of the rod. So now this rod is not going to end up with the same issues and problems and failures that the first one had. And the threaded part of the rod, that is 120mm in diameter and a 2mm thread pitch. And that is the thread that the nut screws onto to hold on the piston. And then behind that is the area where the rear choke goes. And then there is a thread behind that for the locking nut that holds on the choke. So that's a basic idea on what this is going to look like when it's been fully assembled. At the moment we have a gap between the nut and the piston, and that is because it is a nylock nut and I can't screw it on that far. Once everything has been tightened up, and I mean the nut has tightened all the way up against the piston, the front choke, the cushion bearing, can still move. So it will float up and down and in and out and around the rod. So we did tighten up the tolerances there, but it will still do exactly the same job as the original rod, but without the fail points. Now that I've got this end completed, what I need to do is flip the rod in the lathe so I can start the machining on the other end so I can then fit the eye. So we've fitted the eye, we've got that tacked in place. Now what I'm going to do is take it out of the lathe and go get it set up for welding. Righto guys, so that's the eye completely welded onto the rod. I'm really happy with how everything turned out. So now what I need to do is get it strapped onto a pallet and get it back to our customer. Thanks for watching.
Yep.
Pumped. Let's fucking do this. Ready?
Yep.
Righto, now that we've got everything to it... Are we going to talk about down here? Or just do it? Fuck, what do we call this area? Fuck, what do they call those things? If you are to over-tighten those nuts, you have nuts. What we do with the material that we... Fuck. And I forgot everything you
Oh my god, just say it so it's good.
Right, are you ready? Right, so, oh my God, fuck. Brain's broken. Where were we going with that? I'll just start again. Without having that, the relief, fuck, that went just swimmingly. Right. Ready?
Yep.
Right, what'd you say?
Oh my god.
So where do we start from? Come on. But I'm good at England. Really, really good. English, man. Should try German or something.
Might be better, yeah.
I doubt it. Shut up, Joy, you're putting me off. Righto, so I'm getting really drippy. So we've got all the rough turn. Fuck up, man. Like a big train next. And that's to suit the nut that holds on the piston. Fuck off, George. Serious, man. Should be fed today. Go away.
You're so greedy.
Very. Oh, for fuck's sake. It's fucking harder than you fucking think.
Ah, the special bit.
Can't listen. Hang on, I got this.
That was terrible. My poor towel.
That's my towel.